Welcome back to the Flipped Classroom. Our topic today is solving rational expressions, and it's pretty much going to be a review of the things we've done in the past week. So stick with me. I'm going to do a total of 6 problems, and hopefully we can clear up any confusion we had between the 3 different types of problems that we've done. So, get ready for problem 1. Alright, question 1. 1 over x plus 1 plus 1 over x. Off to the side, we want to see in your notebook the terms or words adding fractions. Okay, so make sure you have that written down right in there. And now underneath, we want an asterisk here, and we want you to understand that when you're adding fractions, you are looking for a common denominator. Okay, we want that common denominator. And the second thing we want you to write down is that you want to keep your answer as a fraction. Alright, so we've done a few different things where we keep fractions and kill fractions, but our main goal today is we need to understand that adding fractions, we need the common denominator, and you want to keep the fraction. Okay, so question 1, what is our common denominator? Well, you have an x plus 1 and an x, and remember, common denominator means you need both of them. So I'm going to rewrite each fraction with that common denominator. X and x plus 1. X and x plus 1. So step 1 was to get that common denominator. And now, very simple. I'm just going to ask myself, I have an x plus 1 in my first fraction. I need both of them. So I'm going to multiply my first fraction by x only. In my second fraction, I have an x. I need both of them. So I'm going to multiply the second fraction by x plus 1. And as I multiply, x times 1 is x plus 1 times 1 is x plus 1. And lastly, remember I'm keeping the fraction, so I'm going to make one big fraction now that shares this denominator of x and x plus 1. And I'm simply going to add the numerators together. So x plus x makes 2x plus 1. Now, am I done here? Well, remember, before you can cancel anything, you have to factor first. So if I look at the top, in fact, I can't factor anything, so I guess I am completely simplified. The other things we want to talk about is where that fraction is undefined. And again, that just means your denominator can equal 0. And since I have 2 variables down here, even though they're the same variable, I need to consider when this denominator equals 0. If I look at this first fraction, this first term, x plus 1. The only number I can't use for x is negative 1, because negative 1 plus 1 equals 0. So x cannot equal negative 1. If I look at the second term, the only thing I literally can't put there is 0, so I'm also going to say x cannot equal 0. That will make my fraction undefined. Alright, well, we've got example 1 out of the way on adding fractions. We're going to do one more example about adding fractions. So remember, common denominator, and you want to keep the fraction. So example 2, 6 over x minus 5 minus x plus 5 over x squared minus 25. So before I just run and grab that common denominator, whoopsie, I noticed that one of these denominators can actually be factored. So I'm going to factor first. So I'm just going to cross this off and put in x plus 5 and x minus 5. Now you'll notice something very nice will happen in this fraction. The x plus 5 on top and the x plus 5 on the bottom are going to cancel. So before I even begin, I'm going to rewrite my fraction. 6 over x minus 5 minus 1 over x minus 5. Now, this is extremely nice because I already have common denominators. They are the exact same. So, the only other thing I want to watch out for is that minus sign. I'm going to change this to a plus and make this a minus. So my common denominator is x minus 5 on the bottom, and 6 minus 1 on top leaves me with a 5. Now, I am done here because I cannot simplify this 5 and this 5 without touching this, and all 3 terms don't have something in common. So in fact, this is my simplified answer. The only other thing I want to say again is when is this fraction undefined? And that's when that denominator is going to equal 0. The only number that I can't have here, so what number minus 5 would get me 0? Well, hopefully you're already thinking x cannot equal 5, because again, 5 minus 5 is 0. So Recap, adding and subtracting fractions, get a common denominator, and keep the fraction. Alright, question 3. 7 over x minus 4 minus 3 over x plus 4 equals x plus 25 over x squared minus 16. Now this problem is completely different compared to the first two that we just did. The main thing you'll notice is that they're telling you it's an equation and what it's equal to. Previously, we did not have this side. We just added these two terms together, getting common denominators. So the rules here are a little different when you have equations. So again, off in the side of your notebook, we want to see when you have equations and fractions, we want to kill the fraction. Alright, we are not keeping it. We are not keeping a common denominator. We are killing the fraction when you have an equation. So again, make sure that's spelled out completely clear in your notebook. Okay, now to do this, we're going to do something very similar. We're going to compare all those denominators, and again, you'll notice that this one can get factored. So I've got my x plus 4 and my x minus 4. And now when I compare all those three denominators, I'll notice the common denominator is both x plus 4 and x minus 4. So I'm going to give that to every term, and I see three terms. So I'm going to say x plus 4, x minus 4 to all three terms, and of course in the numerator. Okay, so take the time to write it out. X plus 4, x minus 4. Now the whole point of us doing that is we should kill each fraction. And when I say that, something should cancel on the top and the bottom. So in the first term, the x minus 4's cancel out, and I'm left with 7 times x plus 4, which is 7x plus 28. In the next term, the x plus 4's cancel, so I'm left with 3 times this quantity. I'm going to do one other quick thing. I'm going to change this negative to a positive, and then that makes this 3 a negative. So I'm actually going to distribute my negative 3 to my x minus 4 to get negative 3x plus 12. And the best part about the last terms is the x plus 4's cancel and the x minus 4's, so I'm just left with what was there, x plus 25. Okay, so in the end, you should see no fraction. You have killed the fraction when you have an equal sign. So I'm just going to combine my like terms. That gets me 4x, 28, and 12 plus 40 equals the x plus 25. And of course, just solve for x. So in the end, I get x equals negative 5. Now, you do have to check this answer. So I would carefully plug it back in and check. And I just want to talk about answers that are automatically going to get rejected. And that's when my fraction is undefined again. So I have to consider each separate fraction. So if I look at the first fraction, x minus 4, the only number I can't put here would be the number 4. So 4 would get rejected. The only number I can't put in the second fraction would be negative 4. So of course that would give me 0 as well. And lastly, both 4 and negative 4 in that last fraction. So my final answer, x equals negative 5 checks, and this fraction is undefined when x equals positive or negative 4. All right, let me give you one more similar to this, and then we'll get to our last type that we've talked about. Okay, so here we go again. I've got an equation, so I'm saying to myself, kill the fraction. I don't want to see, oops, that looks a little violent. Kill the fraction. I don't want to see a fraction in my final answer. So again, make sure you multiply by that common denominator. I'm going to scratch that and say x minus 8 and x minus 2, which is very convenient. You'll notice you need an x minus 8 and x minus 2. So every term, remember, gets the x minus 8 and x minus 2. After you've got that written out next to every term, I'm going to run through the problem. You try it on your own and see if we get that same answer. So you can quickly see my answer. Hopefully you got the same thing. I got a final answer of x equals 12. And again, of course, I have to check that answer. But I can pretty much determine who's not going to work. And again, that's who is undefined. So I'm also going to state which numbers are undefined. If I look at that first fraction, hopefully you say x can't be 8. And if I look at that second fraction, x cannot equal 2. So since I didn't get 8 or 2, I know this answer is definitely going to work. So We've had adding and subtracting fractions where you keep the fraction, and then when there's that equation, we're going to kill the fraction. Alright, 2 problems to go, and you'll notice this is completely different from the previous 2. I don't have an equation at all, so keep that in mind. This is called, if you remember, a complex fraction. So again, off in the side of your notebook there, let's get that written out. Complex fraction. And basically, if you recall, that just means a fraction within another fraction. So in this method, again, we're looking for that common denominator, which has been our common theme, and we want to multiply every term by that common denominator. And in essence, we want to make sure that we kill the fraction. So even though this one doesn't have an equal sign, we are still killing the fraction. Alright, so as I look here, my common denominator number-wise out of a 2 and a 4 is a 4, and of course the letter A. So notice every term is getting 4A, and always to the numerator, like we've preached. Alright, and again, I'm killing the fraction. I should not see a fraction on the top and bottom when I'm done. So on the top here, I can reduce the 2 into the 4, which gives me a 2. So on top, I have a 2, an A, and an A, which makes 2A squared. On the bottom, I can kill this, or in the next fraction, this A and this A. So I've got minus 32. And I can kill this 4 and this 4, so I'm left with A times 1 is A, then a minus sign, kill those A's, and a minus 4. So notice I killed those larger fractions to make one fraction. Lastly, I just want to factor anything I can and reduce. So I can pull out a 2, and I'm left with A squared minus 16 over my A minus 4. And in fact, I can go one step further and factor that even more. I can say that's 2 and A plus 4 and A minus 4 all over my A minus 4s. And of course, my A minus 4s are going to cancel. So my final answer, kind of working backwards here, looks like 2 times A plus 4. Or I could say 2A plus 8. Alright, so complex fractions, we're still grabbing that common denominator, and we're going to kill the fraction 2. So notice we've killed the fraction in 2 out of our 3 problems. The only time you're keeping your fraction is when you're adding and subtracting. Alright, well we've made it to our last problem. And I saved the ugliest one for last, of course. Again, it is a complex fraction, even though it may not appear that way. But keep in mind, all these negative exponents should turn into fractions. So let me, help you with the first step, and then hopefully you can fly from there and just check your answer at the end. So I'm going to say the negative exponent turns into a fraction, but notice that negative 1 is only on the x. So I'm going to rewrite that as 2 over x. Again, this negative 2 is only on the x, so I'm going to say that's minus 4 over x squared. Notice nothing's negative, they're just moving terms. I like every term to be a fraction, so I'm going to call this 1 over 1, and then again 2 over x. So from here, I'm hoping you can clean that up on your own. So go ahead, pause me, and then check your answer at the end. Just real quickly, let's just verify our common denominator should be an x squared. So hopefully you can follow my work. I multiplied every term by the x squared, killed those fractions, so I only have one fraction, factored, and I've got a final answer of 2 over x. Okay, so hopefully you've got these 3 types of problems straightened out, and our goal is really just to, practice the difference of them tomorrow in class. So hopefully you've got some good notes and you're well prepared, and we look forward to seeing you tomorrow. Have a great night.